Hey everyone, I'm going to show you how to do exercise 4 on page 263 in UCI's Math 4 textbook. So basically the problem states that a small open economy with a flexible exchange rate has IS, LM, and BP curves given by these three equations. And it wants us to solve it using row operations. So we're going to want to take these constants there, the 240, negative 50, and 105, and rewrite these equations as such, so we can actually start solving these systems. Now to solve these systems, we're going to put these equations in a matrix, so that way we can solve for each variable. So we're just going to plug in the values for these equations, such as negative 240, and then negative 1, negative 4, 1, 50, negative 1, 1, 0, negative 105, negative 1, 1 half, and negative 2. Now to start our row reduction operations, we're going to try reducing either row 1 or row 3, since we don't want to ruin the 0 in the second row, since this second row has basically already been reduced for us. So to do this, we're going to add row 1 to row 3 by multiplying row 1 by row 2, adding the two equations together. Now if you forgot what's actually going on during row reduction, here's what actually happens. So basically the first part of this row 1, row 3 addition thing, the first one is going to be the one that you're just going to use to get your 0 in the second equation, and this equation right here is going to be the one where it's going to be changed when you rewrite your matrices. So written out, these equations, it's going to look like this when we add them together. So row 1 is going to be 2 times negative 240 equals negative 1r minus 4y plus 1e. And then we're going to add that to row 3. And this entire thing is going to be negative 105 equals negative 1r plus 1 half y plus 0e. Actually, that's an error. That should be negative 2. So our new row 3 is going to be negative 585 equals negative 3r minus 15 halves y plus 0e, which is intentional. We were trying to get that 0 right there. So that way when we rewrite this, we can rewrite it as such. So I guess what we're really trying to do in the long run is basically get everything down to a simplified version so we can easily tell which values equal what. So like in this case, I'm trying to bring everything down so that way we can figure out what r equals. Our next step is going to involve row 2 and row 3. And I'm going to try to see if I can get rid of that 15 halves there so we can find out what r equals. Because as you can see, if we do get rid of that 15 halves up there in row 3, we can essentially find out what r is. So we can rewrite this, just in case if you forgot, as 375 equals negative 15 halves r plus 15 over 2 y plus 0 e. And of course that's after we multiplied 15 halves times r2. And we're going to add this to row 3, which is going to be negative 585 equals negative 3r minus 15 over 2y plus 0e. And of course we're just taking these equations straight from the matrix and rewriting them. So this is going to equal negative 210 equals negative 21 over 2r, which, since we can simplify this, we can get row 3 equals 20 equals r, because we only have one variable. And we can use this to solve for the other variables. So we're going to rewrite this as a new matrix again, so that way we don't get confused about what we've already done, and so we can actually see what row 2 might give us. So negative 240, negative 1, negative 4, 1, and then 50, 20, negative 1, 1, 0, 1, 0, 0. And now that we have this, we're going to try to get this down to reduced row echelon form by getting rid of this negative 4 right here, and trying to get that down to 0. So we're going to do that by doing 4 times row 2 plus row 1, following our row reduction method that we've been doing so far. So I just did this on the side. If you want to do it, you can do it out loud, like write out everything. But I'm just going to skip over that and go to negative 40, negative 5, 0, 1, negative 1, 1, 0, 1, 0, 0. Just filling everything out. 50, 20. Now we're going to see if we can get rid of this negative 1 right here, since if we do that, we'll get that much closer to reduced row echelon form, so we can see what the variables are. So we're going to do row 3 plus row 2, which is going to give us negative 40, negative 5, 0, 1, 70, 0, 1, 0, 20, 1, 0, 0. And notice that the negative 70s actually are y value. So we can technically solve for our last value, the e, since we know y and r now. So basically we're going to do this one last operation, which all we need to do is 5 row 3 plus row 1 to get that last 5 up there to be 0, and we'll have our systems of equations that'll give us all of the values for this problem. So as you can see, our values are 60, 70, and 20. And this is actually what the values for r, y, and e are. So by getting that diagonal in this matrix up here to be 1, 1, 1, you can easily see what the values equal without actually having to rewrite everything. And yeah, this is pretty much the reduced row echelon form. So the final answer for the question, I guess our conclusion, our conclusion is e equals 60, y equals 70, and r equals 20. So I hope this video has been a help to you.